Hi everybody, so in video 2150 we talked about a battery that could arguably last forever, and that battery is a Zamboni pile, and since 1840 it's been ringing a bell in Oxford, the famous Oxford bell at Clarendon. Now there is an argument about how it actually works. Some people say it's electrostatic and some people say that it's just very slow corrosion because the amount of energy used to ring the bell is very tiny, and either could be true because nobody has dissected it to have a look, and although it's been running since 1840 that doesn't mean it will run forever, so either argument has the possibility of being true. There is, however, another kind of forever battery that was invented by Karpen, and it's been running for about 60 years or so. The battery named after him is called the Karpen pile, and it's housed in the National Technical Museum in Romania, and it was put together in 1950, and it consists of two series connected electrical piles that move a small motor. The motor moves a blade that's connected to a switch, and with every half rotation the blade opens a circuit and closes at the start of the second half of the rotation. The blade's rotation time has been calculated so that the piles have time to recharge, and then they can rebuild their polarity during the time the circuit is open. It uses platinum gold electrodes, and there is no detectable corrosion effect happening. Now, although the original cell uses gold, platinum and sulfuric acid, there is a patent. It's a French patent, FR 577087, and in that patent 3 arrangements are shown for the Karpen cell, and they use fairly innocuous ingredients including all carbon-carbon version, so I thought I'd give it a go. So I quickly knocked up a Type 3 cell using graphite foil and sodium carbonate, which is washing soda. I put it across a 10 ohm resistor, and you can see the voltage being read there. With a 10 ohm load and a 0.21 volt reading, it means we're getting about 21 milliamps being generated. So something is happening, and it's all a bit of a mystery as to what, until the arrival of this Chinese paper, and of course that got me thinking, so I thought I'd give that one a go. And here is my attempt at a replication. It's a fish tank filled with copper chloride solution and 10 sheets of graphol with copper as the electrodes. So the likelihood of that being galvanic, that is corrosion of the copper, is minute, and in the paper they went to considerable effort to show that it wasn't galvanic corrosion, and they managed to light an LED lamp across it. And my advice, if you have more questions about it, well, I've given you the link to the paper. Have a jolly good read. It is a fascinating read. So if you do read the paper, what you'll find is that the Chinese argue that it's a thermal effect, because of course movement and heat are the same thing. The hotter something gets, all it means is that the molecules are moving that much quicker, and as they move they're hitting the surface of the carbon, or rather the ions are hitting the surface of the carbon, and this is why it's important to have two different carbons, like Karpen said in his patent, because the conductivity changes. So when an ion hits the carbon, then the electron conductivity means that it goes through the outside of the circuit, and so we get a driving force or an EMF. Now if that's true, then temperature should raise the voltage. So let's give that a go. Okay, so we've got it on a heat plate. It's actually aluminium chloride here. We've got a graphite electrode. We've connected it across a 10 ohm resistor. It's at 35 degrees C, and you can see it's reading 2.3 volts. So it's pulling real current. Now, without the temperature on, it began at 1.5 volts and it's raised it to 2.3 volts as that electrolyte has warmed up on the hot plate. So at first sight this might look like mucking around at nothing, but actually it's incredibly important, because what it means is that the Karpen cell was real. It looks like the guy was onto something, and when you think about the research that's coming out, and here we're thinking about water droplets running across graphene creating charge. We're thinking about all carbon batteries that are coming out of Japan. We're thinking about the graphene generators where in sunlight and with a gas across the surface that they will generate coming out of Arkansas. There's a whole lot of very promising research on this coming out time and time again. So it looks like Karpen was definitely onto something. Now you could argue that it's not actually a battery, that it's in fact a thermoelectric effect, so it's a thermal generator. And to a degree I can agree with that, but to another degree, depends what you think a battery actually is. If a battery is all about charge separation, then this mechanism of differential conductivity and thermal effects across a surface are charge separation. So I would say it's a grey area as to whether it's a battery or whether it's a generator. But the most important thing is it actually works, and of course that means there's a very promising avenue to look at in terms of generation that perhaps we're not looking at as well as we should be. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.